Okay, part 2 of 6.2, rationalizing the denominator. That's going to be your instructions. So what that means is you're going to take something that is not rational and make it rational. So we are rationalizing the denominator. And these two are some pretty common ones that you're going to see. You're going to need to make sure that is no longer irrational. So you're going to multiply by whatever it takes to make it not be irrational. But you have to do the same thing on the top and the bottom. So we're fixing the bottom, and the top has to match the bottom. So now you're going to get square root 6 over square root 4. But what is the square root of 4? 2. So that would be your simplified radical. Now over here, I've got square root 5x in the bottom, this index of 2, so I can multiply by 5x, top and bottom. So you would get square root of 10x over, if you need to, you can write it like this, because I've got 5x times 5x, but now the square root and the square cancel out, so I get 10x over 5x, square root of 10x over 5x. But now this one is a little bit different. I've got cube root of 3 over cube root of 2. I'm still trying to rationalize that denominator, but instead of just multiplying by that over itself, I'm going to have to multiply by whatever it takes to make a cube root cancel out. So I'm going to try to make exponents of 3. So I'm going to do 2 to the second power, because 2 to the second times 2 to the first is going to be 2 to the third. So I'm going to do the same on the top. So that's going to give me the cube root of 3 times 2 squared over the cube root of 2 to the third. And now the cube root and the cube cancel out. Now, can I simplify anything in the top? No, I don't have 3 of any prime factor, so I'm going to get 12 over, well, 12 in the cube root over 2. And that would be considered simplified. So now we're going to throw a little bit of extra stuff in there. Same instructions, rationalize the denominator. I've got 5x squared over 12y squared z all under a cube root. If I could simplify anything, top and bottom, I would want to do that. But in this case, nothing will simplify. So I'm going to separate it, top and bottom. But instead of writing it as 12, I'm going to write it as its prime factors. So that would be 2 squared 3, y squared z. Now, I'm still trying to get this radical to go away, so I need to multiply by whatever it takes to make that radical go away, knowing that I'm trying to get exponents to be 3. So I'm going to do 2 to the first, because that would make a total of 3. 3 to the second, because that would make a total of 3. Y to the first, because that would make a total of y to the third. And then z to the second, because 1 plus 2 is 3. So now I have to do the same thing on the bottom. On the top. Whatever matches, whatever I did in the bottom, I have to do to the top. So I'm going to get y z squared. Simplify. So in the numerator, I have 5 times 2 times 3 squared, x squared y z squared. In the bottom, I have 2 cubed, 3 cubed, y cubed, z cubed. Done on purpose so that the cube root will cancel with those exponents. So in the denominator, I just get 2 times 3 y times z. In the numerator, does anything simplify coming out of the radical? No, because I don't have an exponent of 3 on anything. So all of those just need to get multiplied back together. So that's 9 times 10, which is 90. But I can multiply the 2 and the 3 together, so I would do that. So I have 6yz cube root of 90x squared y z squared. And we're done with that one. So I've got one more. exponent of 4. Same instructions, rationalize the denominator. Now, can anything simplify top and bottom? Can anything simplify outside of the radical? Not in this case. So I'm going to see what I need to multiply by to get exponents of 4. So if I do 5 to the third and y to the first, because 1 plus 1 is 4, 3 plus 1 is 4. So now I have to make the top match the bottom. And now multiply. So I have 7, 5 to the third, x, y, over 4th root of 5 to the 4th, y to the 4th. My pen is almost out of ink. Can I simplify anything in the numerator? No, because I don't have an exponent of 4 of anything. So I'm going to do, multiply those back together. So what is 5 to the third? 125 times 7. And it's going to be 5, 35, 14, 15, 16, 17. It's going to be 875. I should probably use a calculator. Over the 4th root of 5 to the 4th, the 4th root of y to the 4th. And we should be done. But I feel like I need to check that. So is 7 times 5 to the third 875? Yes, it is. Okay. Well, then I think I'm finished.